They've intrigued man for centuries, captivating astronomers and astrologers alike. The patterns that once navigated mariners across treacherous waters now guide astronomers to uncover the mysteries that lie within the constellations.
Before the internet, before movies, the night sky and the constellations were the greatest show in town.
This gallery of stars forms more than just pretty pictures. It contains an enormous sampling of star types. Through constellations, we can learn a lot about the galaxy and the universe beyond. Before we had high-tech navigation devices, GPS, or even compasses, we had stars. Like landmarks along the road, constellations can help us find our way. They give us direction, distance, and a sense of where to go.
So on Earth, when we want to tell where something is, we give its coordinates in latitude and longitude. And what that means on Earth is it's a measure of, latitude is a measure of the distance between the North Pole and the South Pole, and longitude is the east-west distance, so the other direction. Similarly, we have a celestial coordinate system.
But the coordinates, they're not called latitude and longitude. They're called declination and right ascension. They are just direct extensions of latitude and longitude on Earth, projected out into the sky.
Ancient navigators used this imaginary grid to plot stars and orient themselves across the seas.
Not a precise kind of indicator of direction, but certainly a cue to keep people reminded of what the broad pathways through the seas might be.
By using a sextant, mariners were able to use guide stars like Polaris to navigate.
This is a sextant. It's a tool used in celestial navigation. Once a celestial body hits what's called its lower limb to the horizon, you'd mark the position. Using the time and the numbers on this sextant, you can then use it in fixing your position at sea.
Today's navigation uses man-made stars, satellites.
With the use of our man-made stars, per se, our GPS positions and differential GPS, we're able to fix the ship's position within a few yards, instantaneously, anywhere we are in the world.
Now that GPS has replaced sextants, celestial coordinates are more important to astronomers than they are to sailors. Peering into the Big Bang, scientists can nearly see the beginning of time. 300,000 years after the Big Bang. Even our most familiar constellations have a lot to teach us about the cosmos. Orion, which is Greek for hunter, has 77 visible stars. Alnidak, Alnilam, and Mintaka make up the 3 stars in Orion's belt. In modern times, astronomers have hunted Orion, finding a variety of astonishing objects.
When I see Orion, I also see the life and death of stars. Just below the belt, there's a little smudge called the Orion Nebula, and that's a nursery for baby stars, and you can actually see that with the naked eye.
Orion has also bagged a pair of stellar gems.
If you look at the upper left-hand shoulder of Orion, you see the red giant Betelgeuse, and if you immediately look right down to the lower right star, the star that's sort of his leg, you'll see the blue supergiant Rigel.
Betelgeuse, as a red supergiant, is a star in its death throes.
A red supergiant is a star that is actually quite a bit cooler than our sun, but much, much larger.
Betelgeuse is 14 times more massive than our sun. When it runs out of nuclear fuel, Betelgeuse will become unstable and implode in a colossal supernova. It can detonate at any time.
And when it explodes, it will light up the entire night sky, and it will even be visible during daytime. and maybe it's already blown up. It's 427 light years from Earth, which means that perhaps it has already exploded, but light hasn't had time to reach us yet.
Taurus, the bull, possesses 98 visible stars. Aldebaran, a red giant star, is the bull's bloodshot eye. Taurus is one of the zodiac constellations that lie near the plane of the ecliptic.
It's called the ecliptic plane because that's the only circle around the sky where eclipses can occur. The moon has to pass through the ecliptic, for example, in order to give us an eclipse of the sun.
It's also the path that our Earth travels along as we orbit the sun. 8 degrees above and below the ecliptic lies a region called the zodiac. Every constellation that falls within this band is referred to as a zodiac constellation.
At any given time, the sun is in a constellation of the zodiac. The sun lies between us on the Earth and a certain constellation.
Because we orbit our sun, the sun appears to move through zodiac constellations that are fixed in the sky. During nighttime, the opposite portion of our sky is lit by the sun. Polaris illuminates the Arctic, governing our sky as a beacon over the North Pole. Lying in the constellation Ursa Minor, it's 2,500 times brighter than the sun. Outshining its companion stars, Polaris A, B, and B. Although it's ruled the heavens as our North Star for as long as we can remember, its reign won't last forever. As Earth orbits the sun, it teeters back and forth. This wobbling is called precession. If Earth was a perfect sphere, it wouldn't precess. But the gravitational pulls of the moon and sun tug at the bulging equator, upsetting Earth's spin.
Now the Earth is like a gyroscope or a spinning top. Notice that if I spin this very rapidly and then I move the axis, it points in the same direction. This is the Earth pointing toward Polaris, that as the Earth goes around the sun, it always points in the same direction. However, precession is caused by gravitational interference, so the Earth begins to wobble.
As Earth wobbles, its axis draws a circle in the sky. It takes 26,000 years to make one complete circle.
The North Celestial Pole will move further and further away from the position of Polaris. In about 14,000 years from now, about halfway around its circle, it will be very close to the bright star Vega. But because Vega is so much brighter than any other star in that part of the sky, it will be a very significant north polar star.
In 26,000 years, Earth's axis, centered on the North Pole, will make one complete circle, and it will point back to where it is today. Our night sky is in constant change. Within each constellation, stars are born, while others are swallowed by black holes. Every supernova explosion, exotic star, and nebula has one thing in common. They are identified by the constellation they're located in. But even before we invented high-powered telescopes to see them, constellations served an important purpose. They brought people the nightly news that they dared not ignore.
It was a question of life and death. You see, the night sky is a calendar. That was the very first scientific invention of us humans, the calendar in the sky.
The rising and setting of the sun, the changing phases of the moon, the seasonal reappearances and disappearances of the stars. People see that there is, in fact, an order to the world. They, in fact, see order in the sky that is useful for them to anticipate what's happening on the Earth. That's a tool for survival.
When you look at the sky, you see these groups of stars that are connected to important events that will prompt you to behave in certain ways or to move in certain ways or to plant or harvest.
Besides seeing the pattern of stars changing with the seasons, the ancients made another crucial observation. The shifting stellar canopy shaped their world.
Travelers who went a long way south, for example, from Greece, started being able to see different constellations from any of the constellations that have been visible in their hometown. So it's telling you that you're really moving on a curved surface and changing your perspective.
Today we understand the shape of the Earth and the parade of the seasons. But constellations haven't outlived their usefulness. Instead of telling us about the Earth, they're helping us make sense of the stars.
A constellation is a lot like an art museum. In an art museum, you'll see artists who have used different kinds of materials, painting, photographs, and ordinary objects. A constellation also has similar objects, but made of different materials. Some of them have more helium or hydrogen or carbon, silicon, iron, and yet we can group them together. In both cases, the objects that are gathered in an art museum or a constellation, they're artificial collections that we've put together for some reason.
Like countries, constellations divide the sky into territories.
When you say Orion, I know exactly what part of the sky you're talking about. So to an astronomer, a constellation really is kind of a handy map. It's just a way of organizing things, so we kind of know where stuff is.
And even though the night sky is infinite, we can see only a sampling of stars before dust and distance blocks our view.
You'll probably see on a very dark night maybe 1,500 to 2,000 stars with your naked eye, if you're not using binoculars or anything. So what we're seeing is only a tiny, tiny fraction of what's really out there. That would be sort of like looking at the whole population of the United States, 350 million Americans, and seeing 5 people.